All right, this is a lesson on atomic structure. Atomic structure means the structure of what an atom looks like. This is what an atom looks like in its very basic form. In this middle part, which is known as the nucleus, we have two subatomic particles known as protons and neutrons. Flying around the outside of this are the electrons. Those are the three subatomic particles. Each have a charge associated with them. Protons have a positive charge. Electrons have a negative charge, and neutrons are actually neutral. In the nucleus, we have the protons and the neutrons. These are the only ones that have mass. We would say that the electrons hardly weigh so much, they're just flying around the outside, that they hardly have any mass at all, and so all of our mass comes from these two subatomic particles. We have to be able to find and use the periodic table to help us each number or quantity of subatomic particle. To find the number of protons, we're going to utilize the atomic number. If we look at our periodic table, we can use these numbers, which are known as the atomic numbers, to tell us the number of protons. To find the number of neutrons, we take the atomic mass, which is actually a combination of both protons and neutrons, and we subtract the number of protons. That leaves us with just the number of neutrons. If we're going to find the number of electrons for an atom, in its atomic state, the number of positives, the number of protons, is actually equal to the number of electrons, which are the negatives. Positives equal the negatives. And therefore, we can just find the number of protons, and that would tell us our number of electrons. If we see an ion is an atom with a charge, a difference in the number of protons than electrons. We have to use that ionic charge to help us figure out how many electrons an atom may have gained or lost. So in this example of a negative ion, you might see N3-. This means that nitrogen is an ion. What the -3 means is that I have gained 3 negative charges. I've actually gained 3 electrons. If you were to see an ion, let's say like this means I've lost negative charges. I've lost 1 electron. And so we'll use this information in a combination with the number of protons, which told us the original amount of electrons, to try and determine the number of electrons in ions. And we'll do a couple of examples to clarify that. In the example of sodium, to find the number of protons, I first need to look at my periodic table to look at the atomic number. Sodium is found over here, and it has an atomic number of 11. That tells us that this has 11 protons. To find the number of neutrons, remember, I need to take the atomic mass and subtract the number of protons. The atomic mass of sodium is 23. So 23 minus my number of protons, which is 11, gives me 12 neutrons. And to find the number of electrons, I need to remember that sodium in its atomic state, or as an atom, has the same number of positives as negatives, and therefore there's 11 electrons as well. In this next example of sodium in its ion form, the number of protons and neutrons are going to stay the same. Still has the same atomic number, meaning 11 protons. It's still going to have the same atomic mass. Subtract the number of protons, gives me 12. But to find the number of electrons, I need to do a little bit of looking. I need to look at the ion charge. This shows a positive gain in charge, meaning more positives than negatives. What that means is I've actually lost electrons. I've lost 1 electron. And so while I should have 11, I've lost 1, and therefore I only have 10. If I look at an example of a negative ion, remember, getting negative means I'm gaining those electrons. So this means gained 1 electron. So to find the number of protons, I need to find fluorine, and I need to find out its atomic number. Fluorine's over here, has an atomic number of 9, so 9 protons. To find the number of neutrons, I need to take the atomic mass, subtract the number of protons. The atomic mass is 19, subtract 9, and fluorine has 10 neutrons. To find the number of electrons, it should be 9 to match the positives and the negatives. However, I've gained an extra 1. So instead of 9, I have 10 electrons.